Hi, so for today, we are going to continue our discussion in dynamics of rigid bodies. So this is still the part 2 of the rectilinear translation or rectilinear motion, free fall. So for this video, we're going to solve three problems. Okay, so let's get started. So if you haven't watched my first video about this, please do so first before watching this. Okay, so number one, a stone is dropped from a captive balloon at an elevation of 1,000 feet. So we have a 1,000 feet. 2 seconds later, another stone is projected vertically upward from the ground with a velocity of 248 feet per second. If g is 32 feet per second squared, when and where will the stone pass each other? So this is another typical problem wherein we have two objects. So for example, this is the height. This is your ground. Okay, this is the ground. So this is your total height of 10,000 or 1,000 feet, I mean. So, yeah, there is a stone to be dropped here, okay, from a captive balloon at an elevation of 1,000 feet. So there is a stone. Let's say that's not a stone. Let's say a simple drawing like this. Here is your stone. So, and another second stone is projected vertically upward. So there is another stone that should be projected vertically upward from the ground with an initial velocity of 248 feet per second. Okay, so the question is when and where will the stone pass each other? So basically, at some point, if this stone 1, okay, stone A is dropped, okay, and this stone B is stone A is dropped and this stone B is projected upward, there will come a time that they will meet. Okay? So again, this will be after some time, this will be your stone A, and after some time, this will be your stone B. So they have the same height. Okay? They have the same uh, height, and we are going to call that, this is total height, and we are going to call that height wherein they meet. Okay? They pass each other. We're going to call that height as h. This is the total height, 1,000 feet. And of course, the distance between the stone A, okay, from rest, that's the total 1,000 feet, okay, up to here would be, of course, this would be 1,000 minus h. Because if you add 1,000 minus h plus h, that's 1,000. And that is the total feet, the total height. Okay. So the question is when and where. So yeah, the one thing's for sure here is that this two stone, stone A and stone B, has the same height at the point of their passing. So yeah, we are going to solve first write the given first. So we have the initial velocity of stone 2 that we have 248 feet per second. And then we have a total height of 1,000 feet. Okay. So, and we have a g that is 32 feet per second squared. Okay. So, and then also, we also have another given here. So, it says 2 seconds later. Okay. So, after the stone A is dropped, okay, 2 seconds later, the stone B is projected. So, we have two times. Okay. So, the time equals this time is the time for the first stone. This is the time for the first stone that is being dropped. Okay, that's being dropped from a height of 1,000 feet. After 2 seconds, that means 2 seconds later, that time would be minus 2, t minus 2. So this would be the time for the second stone. Okay, so that is the how we write the time. So 2 seconds later, so it means 2t minus 2. Okay, so now they have the same height. We are going to use the formula of the S equals V naught T plus 1 half AT squared. Okay? So now, for stone 1, let's try first for stone 1. Okay, the stone one's height is in reference with the 1,000 feet. So its displacement s will become negative because we measure it like this. So it would be negative 1,000 minus h. That's the displacement because the reference is at 1,000 feet. Okay, that's how we did it. Now, equals, the initial velocity of stone A is 0. Okay? Then we have plus 1 half negative 32 because that's the acceleration due to gravity, feet per second squared. Okay? And then multiplied by t squared. We don't know the time. Okay? So if we're going to simplify this, this would be 0. Okay, so this would be negative 1,000 minus h. Again, negative because our reference is at this, and then we're going downward as the displacement. So this displacement can be negative. So we have equals negative 1 half 32 feet per second squared t squared. So this negative will simply cancel. That's the essence why we take it into consideration the direction also of the displacement. So we have 1,000 minus h equals, we have 1 half of 32 is 16. Okay, so we have 16 t squared. Let me just draft first the unit. So again, isolating h, we have 1,000 minus 16 t squared equals h, or h equals 1,000 minus 16 t squared. So that is our first equation. Now, for the stone 2, for stone 2, we're going to use the same equation. Okay? So because that's the equation that indicates or has a height or displacement. So for stone 2, with reference to the ground, of course, and going upward, with reference to the ground and going upward, so that must be positive, okay, displacement. So we have h, okay, because that's the time when that's the height where the stone 2 will meet the stone A. Okay? So that's the height. So h, and then we have the initial velocity, still we have VOT. Initial velocity of stone 2 is 248. And the time is basically 2 seconds later after the first stone is dropped. So that must be t minus 2. Okay, and then we have minus, I've already taken the negative sign here in 32 as the acceleration due to gravity in terms of feet per second squared. So we have 32 times t minus 2, that's the time squared. Okay? So if we are going to, of course, simplify this, so we have 248t minus, we have 296. Okay, if I'm not mistaken, or 496. 2 times negative 2 is 496. So this becomes 16, right? So 16 times minus 16 times t minus 2 squared. Okay, so if we are going to expand this t minus 2, that becomes 2t squared minus 4t plus 4. And distributing negative 16, okay, all throughout the terms. So we have 248t minus 496 minus 16t squared plus 64t, and then we have minus 64. Yan. So 248t minus 496 minus 16t squared. So plus 64t minus 64. So yeah, we only have to do we have combining like terms here? So we have, right? So we have 248t and 64t. We have negative 496 and minus 64. Okay? So if we are going to at least somehow equate this, so this is our second h. Okay, so we're going to equate because the same height when they meet, when they pass through each other. So equating this into 1, so this is equation 2. Equating this into 1, we have 1,000 minus 16t squared. Let us equate first before we simplify. So we have 248t minus 496 minus 16t squared plus 64t minus 64. So if we equate that, 16t squared, negative 16t squared will cancel. So you have 1,000 equals 248t minus 496 plus 64t minus 64. So if we are going to get the value of t, that must be 1,000 plus 496, transpose it, then plus 64, and then we have 248t plus 64t. So let us first compute. So we have 1,000 plus 496 plus 64. So that is 1,560. And then we have 248 plus 64. 248 plus 64, that is 312. So you have 312t. So t would be 1560 all over 312. So that's the time. Time it takes for them to meet. Okay? So you have 1560 all over 312. I guess it's 5 seconds. So 5 seconds. So that's the time they meet. Okay? 5 seconds after they meet. Now, how about the question number 2? When? We answer that. When? 5 seconds after they will meet. And then, where will the stone pass each other? So, where? So, we can simply use any other equation. Since they have the same height, we can use either equation 1 or either equation 2 or this one, in solving for the value na of height. So because they have the same height. Again, they have the same height. So basically, we are going to get h, or the height, 1,000 minus 16t squared. Am I correct? So we simply substitute 16 times t squared would be 5 squared. So that must be 600 feet. Okay, that is our answer for this first problem. So for number 2, pretty much the same problem, but then different way of concept. So you have a stone is thrown vertically upward with a ground velocity of 48.3 feet per second. 1 second later, another stone is vertically upward with velocity of 96. So it's the same point of reference. Okay, with different time frame of being released into air. So the first stone, let's say that would be stone A. This is our stone A. Has an initial velocity of 48.3 feet per second. So let me just rewrite it here. So this would be velocity of first wall or first stone is 48.3 feet per second. So 1 second later, another stone is thrown. This is at time t, the first stone. 1 second later, another stone is thrown vertical upward with a velocity of 96.6 feet per second. So this is the velocity of stone B. Okay, at t minus 1 because 1 second later. How far from the ground will the stone be at the same level? This is B. This is B. B at the same level. So there come a time that they are of the same level because of their given initial velocities. So this is stone A and this would be stone B. So they have the same altitude. Okay? So let's say they have the same altitude with respect to that ground because of the E given initial velocity. So our formula is still the same. So that height is the same. Okay? And that is what we are going to solve. So our given is the initial velocity of stone 1, which is 48.3 feet per second, and the initial velocity of stone 2, that is 96.6 feet per second. Okay. So how far above the ground will the stone be at the same level? So again, the t is the time for stone 1. And 1 second later, that's t minus 1. That is the time for stone 2. Okay, so the height is positive because it goes up. So the displacement is positive. So nothing to worry about the sign of the height. So for the first stone, let us first solve for the first stone. We'll be using the, again, our formula h equals v naught t plus 1 half at squared. So we have height. We don't know the height. That's what we are going to get. So we have 48.3. We don't know the time also. Then minus 1 half because of 32.2 feet per second. Then we have t squared. So if we're going to simplify this, that is 48.3 t minus 16.1 t squared. 1 half of 32.2 is 16.1. So this would be our first equation. Now for stone 2, that is still the same. Okay, but we have different initial velocity. The initial velocity of stone 2 would be 96.6 times time. Minus 1 half 32.2 and then t. Oops, this is also the time for stone 2 is t minus 1. So this has t minus 1. Then we have minus 1 half 32.2. Then we have t minus 1 squared. Because we are solving now for the stone 2. So again, we can simplify 96.6 t minus 1. Then we have negative 16.1. Then t minus 1 squared. We can furthermore uh, distribute this. So we have 96.6. Okay, 96.6. Then we have t. 96.6 times t is 96.6 t minus 96.96. Okay, minus 16.1. This is multiplied to the expansion of this t squared minus 2t plus 1. Okay, so we have 96.6t minus 96.96. Then we are going to multiply, including the negative sign here, distribute. So we have negative 16.1t squared minus we have, or plus we have 32.2t minus 16.1 only. Okay? So again, if we are going to solve this, combining like terms, so yeah, or we are going to basically equate these two, okay, we are going to get canceled for 16.1. But let's just first simplify this. We have 96.6t, 32.2t, okay? So we have, if we add that, that would be 128.8. So yeah, we also have negative 16.1t squared. So there's no other t squared in the term. So we cannot simplify that. We have negative 96.96 minus 16.1. They will add negatively. So the result would be negative 112.7. That is our equation 2. Since they have the same height, they have the same h. We can equate equation 1. Equation 1 and equation 2. So upon equating that, so we have 48.3 t minus 16.1 t squared equals, we have 128.8 t minus 16.1 t squared minus 112.7. So again, this will cancel. So we are left with 48.3t equals 128.8t minus 112.7. So if we are going to combine like terms, so we have 112.7 here. We have 128.8t minus 48.3t. Okay, so if we do that, we have 128.8 minus 48.3 is 80.5t. So divide both sides by 80.5t. So cancel. So you will be able to get the time where they will meet, when they will meet. So if we do that, that is 1.4 seconds. So that's the answer. When? Okay? Or I mean that's not the answer. That is the time they will meet. Okay? 1.4 seconds. So how far above from the ground will the stone be at the same time? So we can either use equation 1 in solving the height or equation 2 because it has the same reference. So we can use equation 1, 48.3t minus 61.1 t squared. So you have 48.3, 1.4t. That's the time. Minus 16.1 t squared. It's 1.4 squared. So if we do that using our calculator, so we have 48.3, 1.4 minus 16.1. Then we have 1.4 squared. So we have 36.064 feet. 36.064 feet. So at that height, they will meet. They will be at the same level. Okay? So basically, equating heights, equating those equation will make you solve this type of problem. So for our last problem for this video, so we have a ball is shot vertically into the air with a velocity of 193.2 feet per second. After 4 seconds, another ball is shot vertically into the air. What initial velocity must the second ball have in order to meet the first ball 386.4 feet from the ground? So the same problem, but the ones that being asked is the how much uh, initial velocity must the second ball be fired so that they will meet in 386.4. Okay. So again, if we are going to do that, so we have 386.4. That's 386.4 feet from the ground. And then we have a ball shot from the ground. First ball, that this is our first ball, which has 193.2 feet per second. And after, this is in terms of time. Let me just draw my drawing very clear. So we have this one, the first ball, with 93.2 feet per second. This is time. So after 4 seconds, so there is another ball that is fired. Okay, this is the four. Now, the question that is being asked, what must be the initial velocity of this ball so that they will meet, okay, 386.4 feet from the ground. So later at this time, the ball will be here, ball 1, and later at this time, the ball will be here. So the question is, what is the initial velocity of the second ball so that they meet? So again, our given is we have the initial velocity of the ball 1. We have 193.2 feet per second. Then we have the time. This is the time for the first ball. And after 4 seconds, that's t minus 4 time for second ball. Okay? So, yeah, they must have the same age. Okay? So, the height of ball 1 is equal to or equal to the height of ball 2. So, that is 386.4. Okay? So, we are going to solve still first using that equation. So, for the first ball, we have here h equals v naught t plus 1 half at squared. So, but the h is given, that's 386.4. And the v naught, of course, it started from rest, so it's 0. Okay? So that we have minus 1 half 32.2 t squared. So the minus is because of the uh, acceleration due to gravity. So what happens for the first ball? I mean, no, the V naught is not 0 because it has an initial velocity. I'm so sorry. The initial velocity would be 193.2 times time minus 1 half 32.2 t squared. So if we are going to rearrange that, that would be 193.2 t. This becomes negative 16.1 t squared again. By quadratic equation, okay, we can actually rearrange this. So transpose this here as well as here. So that becomes 16.1 t squared minus 193.2 t plus 386.4 equals 0. So we can solve the value of t by quadratic equation. So yeah, this is our label of A, coefficient for A, B, this is our C. So we need to get that because if we solve for the second ball, we should know the time, T, okay, before we solve the second ball. So yeah, we have mode equation of 3 quadratic. So we have 16.1, we have negative 193.2, then we have 386.4. So the values of t would be 9.46. Okay, 9.464 second. So the time is 9.464 second. That's the first root that is being solved for the time. And the other one is 2.54 seconds. So 2.54 seconds. So 2.54 seconds. So now the correct answer here for time is basically the letter or the first one. Why? Because 4 seconds ago, 4 seconds later, if we are going to use this as 4 seconds, okay, 2 minus 2.54 minus 4 would be negative. And there's no such thing as it would violate our condition, t minus 4. So yeah, that would be the answer. We cannot allow the second one. So for the second ball, we can now solve. So same formula, S equals V naught T plus 1 half AT squared. We already know the time. So we already know the height. That's 386.4, the same height. So the V naught we don't know. But the time for the second ball is T minus 4. Then we have minus 1 half 32.2. Then we have t squared is t minus 4 squared. But we already know the value of t because we have solved it already. So you have 386.4 equals v naught. So that is 9.464. 9.464. 464. Is it correct? 9.464. Yeah, 464 minus 4. And then we have minus 16.1 again. And then this will be 9.464 minus 4 squared. Okay, so upon solving that, we have 5.464 minus we have 16.1. Then we have 5.464 squared. Okay, so we can get the value of V naught here by simply solving this. Just me. So you have 386. So at 386.4 equals the V naught. Yeah. Then we have 5.464 minus 16.1. Then we have 5.464 squared. Shift solve. So let's try to input some value. Let's say 180. Okay, that's 158.69. So our value of initial velocity 158.69 feet per second. So that must be the initial velocity in order for the initial velocity of the second ball in order for them to meet with the first ball with the given initial velocity also. So that's it. So I hope you learned something from this video, and thank you so much for listening. Again, this is Engineer Abat. See you again for many rectilinear translation tutorials. Okay? So thank you so much and God bless.